Hi, greetings of the day. This is Manjunath, your chemistry tutor, and today's topic is quantitative electrolysis. So, this is for grade 12 electrochemistry. Today's essential question is, how is the amount of substance deposited at an electrode related to the electric current, the quantity of electric current passed through the electrolyte? The learning objectives are to deduce the relation between amount of substance deposited at the electrode and the number of electrons lost or gained. So this relation we can deduce starting from the half equations, oxidation half equation or reduction half equation. And then the next learning objective is to calculate the amount of substance deposited at an electrode using the amount of charge that is passed through the electrolyte solution. Okay. So welcome to the class. Let's begin the class with a brief review of what we had discussed in the previous unit. So join the Nearpod. I've shared the link on the chat box and let me know about how you understand electrolysis. What is electrolysis and what are the products of electrolysis of molten sodium chloride? You have 3 minutes for this. Yeah, 3 minutes are done. So let us look at the answers. So student A, electrolysis is passing direct current through an electrolyte. Perfect. Yes. So electrolysis requires direct current. It does not happen with alternating current. However, student A, what happens when you pass direct current through an electrolyte? Yes, you said it. So the electrolyte will undergo decomposition. And sodium chloride decomposes to sodium and chlorine upon electrolysis. Perfect. Good job, student A. Then student B, electrolysis is decomposition of a compound upon passing electric current through it. So student B, your answer is very right. But do you think it's any compound or any particular type of compounds? Yes, so it must be an electrolyte. So electrolysis is possible in case of an electrolyte and not for any compound, like particularly not for a non-electrolyte. And then electrolysis of sodium chloride yields sodium and chlorine. Of course, chlorine atoms are formed, but chlorine atoms are very reactive. They'll readily combine to form chlorine molecules. Okay, so student C, electrolysis is a redox reaction. Perfect, brilliant. Okay. Yes, it's a redox reaction. Cations get reduced at the cathode, anions get oxidized at the anode, and electrolysis of sodium chloride produces sodium at cathode and chlorine gas at anode. Okay. Perfect. So very excellent job done by all of you. Okay, so let us briefly examine the electrolysis of molten sodium chloride. So these are the half equations. This is the reduction half equations, the oxidation half equation. So student D, by looking at the reduction half equation, can you tell me what is the relation between the amount of sodium deposited at cathode or formed at cathode and the number of electrons? Exactly. So formation of 1 mole of sodium will require 1 mole of electron. Okay. So amount of substance deposited at an electrode or formed at an electrode is related to the number of electrons lost or gained. And electrons are charged particles. So amount of substance deposited or liberated at an electrode is related to the amount of charge passed through the electrolyte. Okay. So let us look at what is the amount of charge carried by electrons. So the charge on each electron is 1.6021 into 10 to the power of minus 19 coulomb. 1 mole of electron means Avogadro number of electrons. So charge on 1 mole of electron would be the Avogadro number into charge on each electron. So that comes to 96,487 coulomb per mole. And this number is called as the Faraday constant. It is the charge due to 1 mole of electrons. Okay, so student F, by looking at the half equation for formation of silver, can you tell me how many moles of electrons are required for formation of 1 mole of silver? Perfect. 1 mole of electron is required. And what is the charge due to 1 mole of electron? It is 96,487 coulomb. So student F, so can you tell me for magnesium, how many moles of electrons are required? 2 moles of electrons, perfect. And what is the charge? The charge required would be 2 into 96,487 coulomb. And student G, so can you tell me how much amount of charge is required for formation of 1 mole of aluminium? Brilliant. Formation of 1 mole of aluminium requires 3 moles of electrons. Therefore, 3 into 96,487 coulomb of charge. Okay. So excellent response. So now we are all set to solve numerical problems. So let me take you to the whiteboard. I'll share the whiteboard where we can solve the problem. Okay. So calculate the amount of charge required to form 20 gram of calcium from molten calcium chloride. So student H, can you give me any suggestion as to how I can solve this problem? What is my first step? What is my approach? Yes, so from half equation, we'll get an idea about the relation between amount of calcium and amount number of electrons. And from number of electrons, we get the idea about the amount of charge. So first thing, we write the half equation. Calcium 2 plus gains 2 electrons at the cathode and giving rise to formation of calcium. So according to this equation, 1 mole of calcium, formation of 1 mole of calcium requires 2 moles of electrons. But in the question, how many moles of calcium are there? They are given 20 grams of calcium. So we need to find the number of moles. Number of moles would be mass divided by molar mass. For calcium, molar mass is 40 gram per mole. So number of moles is 0.5 mole. So for 1 mole of calcium, 2 moles of electrons are required. Therefore, for 0.5 mole of calcium, we need 1 mole of electron. 1 mole of electron. And the charge due to 1 mole of electron is 96,487 coulomb. So formation of 20 gram of calcium requires 96,487 coulomb charge. Okay, so that's it. So now it's time for teamwork. I divided the class into 3 sections, and each section has been assigned with a numerical problem. So I provided the Padlet link in the chat box. So go to the Padlet link and solve the form teams, like in the respective teams, solve the respective problems. You have 5 minutes for this. Yeah, the 5 minutes are done. So let me check the answers. So section 1. So the amount of charge required is 4.28 into 10 to the power of 5 coulomb. Perfect. Accurate value. Section 2. So amount of charge required is 2.89 into 10 to the power of 5 coulomb. Brilliant. Section 3. Amount of silver formed is 1.08 gram. Excellent. So good job done. All of you have done a great job. So now it's time for the exit slip. So go to socrative.com and log into the room. I provided 4 simple multiple choice questions. So I'm sure you'll all be able to answer it well. Okay. So a wonderful job done by all of you. Excellent, brilliant. Have a great day. See you in the next class. Goodbye.